Hello everyone, welcome again today. So today I would like to explain about how the Wolfram Mathematica can be a learning tool, especially for the probability and statistic at the PhD level. So you know that in this case, the PhD level might be seem more theoretical in the sense that they need to explain the principles and application of the probability and statistic in the very rigorous manner. Because again, this is the PhD level. So not the audience of this topic might be limited to only graduate students or the economics researchers, economics and financial researchers at the graduate level and or PhD level. Okay, so basically again, this is the new books that I think it's quite good. Of course, there are always equivalents good books in the econometrics, but this series of by the Bruce Hansen, if you see the website here, it's actually is quite good because it's the PhD economy in econometric courses in the 1 year. So this is the main book of the econometric. But before understanding this one, understanding of this level probability and statistics for economics is also required. But again, recall this is a PhD level. So some of the reader might feel this is too high. But if you want to do at the doctoral levels, especially in the econometric, these references are very good. So let's go to the website. So you can see the website here. You can see here. Okay, so this is you can see again, there are two books. So probability, statistics, and economics, the first one. So this is the book. You can have a look here. Oh. Okay, the second one is the econometrics, and of course they have the code here to report in the book for the probability study and econometry is as well as the econometrics. They have also data, programs, and source. Of course, both books are published by the Princeton University Press, so which is again a reputable. So that's why I believe the quality is quite good for the books published by the Princeton University Press here. Okay, so again, in this class, in these sessions, I would like to explain how the Mathematica Wolfram can be used for the learning tool. Again, this is just an example, not covering all the topics, just the first two chapter example. So basically the Hansen books, econometric, especially provide the example and program in the three famous well-known language: Stata, commercial, MATLAB, also commercial, and also R. So the argument of the Hansen, if I read his book, is it's good to be familiar with the several software. Okay, so however, again, in this video, I would like to explain the Hansen, the first session, the probability and statistics for economics, two chapter example, but again using Wolfram. So we know that Wolfram Mathematica is mainly used by the mathematicians, and but we can see that's the application, and it's quite easy to see how Wolfram can help this probability and statistics for economists as well as the foundation of econometrics. So let's go to the two chapters. The two chapters cover in the book. Actually, the first chapter is the basic probability theory and then random variables. So me open the Wolfram notebook. Okay, so let me open the Hansen books. Okay. Notebook Wolfram. There we go. Just wait for minutes. Yeah, okay. So, okay. So this is what I like with the Wolfram Mathematica because it's quite direct. Okay, so I opened my notebook. So this is, you can see, let me bigger. So this is the probability estimate for Hansen. Let's go to the chip chapter. So there are some example, for example, basic probability theory. You can see some basic calculation of the permutation or combinations. So the factorial is easy calculate, and you can see the notation here, permutations, combination, and some example in the book. The calculation again we can easily implement in the Wolfram Mathematica. And there are also interesting example of the poker. So if you want to estimate the probability of the poker hands, see the textbook example, and then we can easily also calculate. Of course, Mathematica is show the exact number in the fraction. So if I want to show in the decimal, it's possible to do this very small, as well as the second example. So we can show this is 0.024%, and then the next pair is better chance, and also this is higher. Okay, and again, so let's go to the more complicated issue. So, for example, according to the binomial theorem, so we can have the expansion of the a plus b to the power of 5. This is equivalent to the sigma of the binomial 5k like this. Okay, so you can see trace here. Okay, so we try to generalize. How about tens? Yes, you can easily expand, show, and this is also the binomial. Again, we test mathematically if this expand and binomial are the same, so left hand side should be equal to the right hand side. So we see, and then it's true, as well as this one. If we want to make like expand and then we make the formula again, this is true. So this is Wolfram Mathematica is pretty good at providing like abstract or conceptual example in a theorem or proof we want to do. And the second is random variables. Yeah, okay, transformations. For example, if y is xx squared, so xx is the three components, so y will be either 1 or 0 here. So expectation, there are some a bit complicated here. So this sigma from 0 to infinity is 1, but if we try to calculate this one, is does not convert. So there is a theory of some calculation might not go to conversion. And then for the continuous random variable, so this is the example of the uniform. For x negative, it's 0, and then for x higher than 1, it's 1. So it's any one between 0 and 1. So this is a bit complex to write the piecewise. So basically, the function of f218 is a function of the x. So it's piecewise of 3 situation here. But once we write the simple one, when we make plot here, so you can see when x is less than 0, the graph is 0. And then for the x is higher than 1, it will be 1. And then here, we can try to the exponential here. So, okay, let's do fixed wheels, okay. And then, of course, below 0, there is no, as also 0. How about the density? So let's make the bit more complex. So the density will be differentiation like this. So we got 1. And then differentiation of the f2 to x will be, you can see the differential of f281 is for 0 x between 0 and 1, you can see 1. And then if 1 dx, okay, clear, this is here. So you can see we can perform the differential, and integration is quite easy in Wolfram Mathematica. And then the notation and logo, you can see a symbol is similar to what we learn in math. So you can, this is personally what I like with the Mathematica here. So you can also do the integrations. Okay, this number is -1 plus a. Again, the exact number I want to show in the decimal. Okay, you got what, 0.23, which is similar with the number example in the textbook, chapter 2. How about there are some also calculation in the expectation like this, so easily 1/3, and then this is a bit complex, y a lambda, and you can find lambda. But of course, if the RE lambda is higher than 0. Okay, how about the function with the p and square? Okay, let's try again, integrate again, does not convert again. Mean and variant, this is the example. Okay, we can find this one example again. Symbolic calculation is, that's the best in the Mathematica. For the Turun kata sensor, you can see also this complicated can be simplified this. Again, this is the good news of Wolfram Mathematica here. Again, the symbolic calculation, especially if we are interested in the theory, is much better in the Wolfram notebook, you can see. Okay, so that's all. Again, this is just only for the introduction, how the Wolfram notebook can help to work on the probability and statistics as well as econometrics in the PhD level. Thank you very much.